Okay, so part of the reason why we're having this meetup tonight is, well, the number one reason is that we wanted to talk about Docker. It's something that's on everyone's mind, it seems like. I mean, who here has not heard of Docker? Okay, let's do a little exercise then. Who here has heard about Docker before this meetup? Okay, yeah, okay. So it's pretty interesting. There's a lot of momentum going on right now, a lot of movement. It's shaking things up a bit. And I've known the CloudSoft guys for quite a while, almost since the beginning of the cloud camps that I organized 5 or 6 years ago. And I knew that they were putting together this project, and it was specifically for deploying applications into Docker containers. So they're over here visiting from the UK. Thought it'd be a great opportunity to have them speak, and especially since the creator of Clocker was coming. And so that's who I would like to introduce next. Andrew Kennedy, who, come on up, Andrew, is the creator of Clocker, which is a project within the Apache Brooklyn software project to deploy applications into Docker containers. So go ahead and get set up here. And the other thing I wanted to say just real quick is that after Andrew speaks for a bit, we're going to have a couple other folks talk about how they're deploying into Docker containers using Clocker as well. And we'll have Jarrett Burial, Jarrett Burial of Push Technology, Justin Fu of MemSQL, and Todd Greenstein of Couchbase. And then we'll wrap it up. So with that, I'll turn it over to Andrew and take it away. Please, let's give him a round of applause for coming all the way over here.
Hi. Actually from Scotland, not just the UK, although it's not a separate country yet. So next week, yeah, so I'll be doing this.
Use the mic.
Yeah.
So we can take that out and eat it.
All right, is that better?
Yes. Yes.
Okay, so my name's Andrew Kennedy. I work for a company called CloudSoft. Software engineer there, working on open source technologies and Java development. At CloudSoft, we do cloud management. We've got our main product is Brooklyn, which is recently open source, part of the Apache ecosystem. And what we're going to talk about today is an application that runs on Brooklyn as part of a stack. So the three components there are Docker, which is the base technology, Brooklyn, which is our software, the enabling part, and Clocker, the part that ties it all together. So Docker, well, as we said, everyone knows about it. There's a huge ecosystem built up around it. New Docker-based projects appearing basically every day. You'll read about it on Hacker News and TechCrunch. There's always something new. Some things it doesn't do very well, or it doesn't do yet. Networking, it's great on a single host, but multiple hosts, that's kind of a problem. Orchestration, you've got Docker files, but that's it. You can use Docker Link, you can link apps together, but again, it's not doing everything we want. And applications, again, they're defined with Docker files, and it's a single service. You can compose them, you can build them together, you can build your app out of microservices, but it's not perfect. So, there's things, Kubernetes has got its pods and so on. So this Clocker is also trying to solve that problem. So I think this is kind of obligatory if you're talking about Docker. Everyone's got to one of these slides just showing it saves you, well, you're not running multiple operating systems. The Docker engine is taking the place of the hypervisor and so on. So if you know about Docker, you've seen this slide, it's in every presentation. So essentially, this is what we're setting up with Clocker. We're setting up this bit on the right. We're setting up the Docker engine and deploying apps to it. So the technology that we use to set up Docker is Brooklyn. Like I said, it's a new Apache project. It started at CloudSoft about 2.5 years ago, at CloudSoft, we donated the code to the Apache Foundation. So it's in the incubator stage at the moment. It's been there for just a couple of months. We've not made a release yet. We're working on that. It's at version 07 snapshot. It's out there, and the Apache codes, you can go and have a look at the web page. So what is it? It's an application management platform based on autonomic computing concepts, which is the idea you have a tree of entities. Each entity, when it's managed, manages its children. These entities are essentially services. We put them together into a blueprint for an application and manage that. The blueprint describes, like I said, services. Each an entity is a service. The configuration that you have for that entity, it's a web server, it's a WAR file, it's a database, it needs some DDL, you've got config files, you've got XML, you've got JSON, stuff that needs uploaded, you want to configure the number of threads and so on. It also provides attributes, so you can do more than just, once you've deployed it, you can read back information about that application. Those are called sensors. Again, that's an autonomic computing term. And you can do things to the entities that you deploy. So actions like, these are called effectors. Actions like resize a cluster, again, deploy a WAR file, execute some DDL, run a Docker command, that kind of thing. So what does Brooklyn actually do when you want to launch an application? Well, you start off, you deploy the app, you need to provision it, you need to put it somewhere. So it uses JClouds underneath. So JClouds is a Java cloud driver, talks to pretty much any cloud API, and it can provision a virtual machine, or OpenStack, CloudStack, AWS, anything you want. It'll then download whatever resources you need, tar archives, that kind of thing. Install whatever shared components, packages, run apt-get, yum, stuff like that. And then configure instance-specific stuff rather than the shared things that are common to every instance of an entity. Configure them, set it up, ready to run. Then, once it's running, Brooklyn will manage it. Again, I've mentioned attributes. It will report back data, current load, number of connections, the kind of useful stuff that you want to monitor in an app. And it'll provide that in a RESTful API, so you can go and consume that in any kind of enterprise management software. And on top of that, you can do useful things with those attributes. So we have policies, you can look at them, look at, say, the CPU usage again. It's getting too high, we can scale out the cluster, increase its size, do something useful. Basically, call these actions, execute an effector, do something. And this is what one of these applications would look like. It's a YAML file. It's defined as part of the Oasis CAMP specification. So Oasis have CAMP and Tosca. CAMP is Cloud Application Management Platform. I think it's a spec. You can see it's describing there. It's a location. Where's it going? It's going to software in Amsterdam. A service. What's that? Well, it's a Node.js. And Brooklyn config is configuring that service. So there's a Git repo, the file name for Node to execute, and the app name. So that's a pretty simple one for a kind of hello world app, but it gives you an idea, and these can get pretty complex. You can put policies in, and so on and so forth. So the entities that we saw there, services there, you can see service type, that's a class name, Brooklyn.entity. So an entity is essentially a service, or in the Docker world, a microservice. In Brooklyn, we've got lots of these predefined, open source and Apache projects. So we've got entities for Couchbase, Cassandra, the kind of bog standard Tomcat, Solar indexing, that kind of thing. There's a lot there, and you can look at source code, or we've got some pages on our website that will tell you. And we can control these entities, like I said, with effectors, or we can do things to the servers that they live on via SSH. So SSH is the API we use to actually do stuff to a deployed entity. So SSH into it, as long as you can do that, we can manipulate the entity, run a command. So Clocker, on top of this, Clocker is Brooklyn plus Docker. What's it doing with Docker? We're putting together the Docker host, we're finding a VM to run it on, so that provisioning somewhere for it to go. We're then installing the Docker engine, configuring that, setting up whatever is required, setting up the ports, the security groups in your cloud environment. Basically, automating the deployment and installation of Docker on a virtual machine. Just basically a series of SSH commands, and off we go. We've got a Docker engine running. And then, of course, we're monitoring it, pulling back information, how many containers are running, can I start another container, stop a container, get information about them. And it's not just one host, it's a cluster of hosts. And each host has got a cluster of containers, and the container is exactly as you'd expect. It's an entity that contains, well, a Docker file that runs whatever app you've decided to deploy with Clocker. And that'll run whatever commands and services that the entity requires. This is a sort of quick architecture diagram. I used to have a lot more complicated one, but I think this gives you the gist. It's an application. I explained that Brooklyn has a tree structure, so at the top there's the infrastructure, children of that, the Docker hosts, and each host has, as its children, Docker containers. So it's the idea we have a cluster that's resizable of hosts, we can add more, and each host is a cluster of containers, and we can add more to that. And in the same way that you can deploy things with Brooklyn to the cloud, once Clocker's up and running, we get a Docker location, and that's somewhere I can now deploy apps to. It's kind of Brooklyn on Brooklyn. We've created a new location you can go and deploy blueprints to, and they'll appear, instead of in VMs, they'll appear in containers. So Clocker is got two sides to it, to the way we manipulate Docker. There's the demand side, so I want a new container, I've deployed an application, it needs to go somewhere, so I find a host, create a container there, and run my Tomcat, run my Solar, run my Cassandra node on that. Maybe I've got a cluster of Cassandras, I want to resize that, add a new entity, it's perhaps triggered off by some auto-scaling policy. So this is the demand part of it. Then on the supply side, we basically decide where does this new container go. So because we've got more than one host, we can actually make intelligent decisions. It's not just we've got a host, add a new container. We've got 3 hosts. Maybe one's close to me, maybe one's in America, one's in the UK, so I choose the local one. Maybe one of them's got far too many containers already, so I don't use that, I choose another one. Maybe they've all got the same number of containers, but the load average is too high on one. So we can make sensible decisions about where to put the containers, not just choose the host that we're running Docker on. And there's various strategies, they're called placement strategies, depth first or breadth first, kind of standard, do we round robin across, or just fill the first one. Simple affinity and anti-affinity, deploy something that's got to be next to another entity or a service of a particular type. Or do I do it, share out resources, use Docker CPU shares and memory shares to configure how to pack the entities into the containers and hosts. And this is all, it's all using the same YAML blueprints that Brooklyn uses to deploy to the cloud. So if I've written a blueprint to deploy to software or OpenStack, I can use the same thing and off it goes to Clocker, and instead of VMs, it's containers. you can do extra things, like I said, the affinity rules, the placement strategies. You can configure Docker files, which obviously doesn't have any meaning if you're deploying to the cloud, but you can add Docker-specific configuration. So Clocker is letting me take an app that I've defined for the cloud and maybe make some separate decisions, deploy it more sensibly into Docker containers. Or maybe I use the same blueprint, I deploy it to my laptop in containers, and then same blueprint, off it goes to the production cloud environment that I use without any changes. Okay. So, to kind of give you an idea of what it actually looks like, this is Brooklyn. I'm running Clocker here. Clocker is a tree of entities. There's an infrastructure. It's got Docker hosts. In fact, there's only one of them. That Docker host, it's got one container, and so container, what's the container running? It's running a node service. I can look at that. Here's my little node app that I deployed before. I can look at sensors on there. Well, I can look at the configuration of it and so on. Now, if I take, this is just another blueprint. This is a slightly more complicated node app. And here, deploying application just by handing it the YAML file. And you can see the location there is my Docker cloud, so it's going to Docker right here. There we go. So if I refresh this, one of the nice things with this, it's another Node app. So because I've previously deployed a Node application to Docker, Brooklyn Clocker has created a Docker image for Node apps with Node pre-installed. So the second time I go and deploy an app that uses a Node entity, it starts from further down. It reuses that image. I don't need to worry about creating Docker images. They're all just maintained for me by Brooklyn, by Clocker. And this is, at the moment, it's a single host, but obviously that can be extended to Docker repositories, key.io, that kind of thing. While that's starting up, we can also look at the Docker host. So you can see here we've got bits of for the sensors. Yeah, so we can see the CPU over there. Perhaps I could use that in a policy that says increase, scale out this cluster here of hosts, create another host, my CPU usage gets up 70%, something like that, or if I'm running out of RAM, that kind of thing. Created 2 more containers, one for my Redis server and one for the node server. So that's starting up. It's not started yet, so obviously this is not the most interesting thing, waiting for stuff to provision. You've got to download stuff, yeah, it takes time. Right.
There's a question, Andrew.
Yeah, sure.
What's a sensor exactly?
All right, sensor is, that's what I started. We use these autonomic computing terminologies. So sensor is just data about an entity. Sensor is data about it. An effector is a thing you can do to an entity. Yeah, so sensors, well, right. So this is the host sensors list. and you can see we've got the host name, we've got IP address of the host, we've got the private IP address, CPU load, yeah, that kind of thing. It's just metadata, information about that entity, and in this case the entity is a host. We can examine what's going on with this Redis chat. Yeah, it's installed, so remember it's taking its time to do stuff. Well, we can show you that once it's finished. That can go.
Andrew, there's another question.
Oh, sorry, yeah.
Can you subscribe to sensors or event off of sensors
Um,
and things?
Yeah, that's exactly how policies work. In fact, yeah, everything goes onto an event queue. A policy subscribes to events that are created when a sensor changes, and then, yeah, you do something inside the policy, kick off an effector, where you get some kind of, yeah. Right, so Quokka, it's a pretty new project. It's been going for 3 months. I think about that. There's been a few simple apps built so far, and it's all based on this Docker driver for JCloud. So in fact, this is something that you can use outside of Quokka. It's part of JCloud's lab. So if you use JCloud in your applications to spin up cloud VMs, you can use the JCloud's Docker driver to use exactly the same code, but you get a Docker container. And that's how Brooklyn, well, how Quokka does its stuff with the containers rather than VMs. So, yes. So I can't see what the next slide is. So there are limitations. Yeah, this is what happens when containers go wrong. There are things that we can't do yet. It's simple apps, and yeah, we need to improve Quokka. So I'm going to show you some of the roadmap items, some of the things that we're working on now, and trying to new features that we're adding or are in progress. And it's version 0.6.2. It's pre-version 1, and it's actively being developed. Oh, not sure what's going on there. I don't think it's hit the laptop. Okay.
Nobody breathed.
So, yeah, one of the things, the limitations I've come up against.
Yes, talk through it.
Yeah, well, the limitations I've come up against developing Quokka, some of them are things inside Docker itself. So Docker doesn't have seamless networking between hosts. Some of them are problems with Quokka, application requirements. Simple apps, it's a VM and you run a service. But more complex apps don't necessarily just convert directly to running in containers. And it's not unique to Quokka. You'll see that anytime you try and convert things to Docker, to containerized form. And there's also those features that users have requested, things that we don't do that people think, that might be nice. So the first thing we're looking at is trying to add more intelligence to placement strategies. I described them, but there's a lot more you can do. If I need a 32 gig container and I don't have one, I can start another Docker host in the cloud. I just go and ask for it. That's a VM that's got 32 gig. If I need 32 1 gig containers, I can, well, again, I'd ask, do I have that spare? Or I'd fit that in, find out which hosts I've got that I can pack those containers into. You do the same thing with cores, so CPUs, fractions of CPU, and it's user-defined strategies would be really nice, being able to just define the way you want to pick a host using a scripting language. Just dump in a bit of Ruby or Perl, and that says, yeah, this is how I pick my host to deploy my containers. Ways of defining applications. Oh, yes. So at the moment, it's restricted. We don't use things like Docker Hub or Key.io, things like that. So that's something I'm looking into. At the moment, if you want to use a Docker file from there, you've got to copy and paste it put it somewhere or just put the link to the Docker Hub or the key.io URL inside your blueprint, but it would be nice to have tighter integration there, so certainly looking at that. And there's other ways to describe applications, so linking into those. But I think the most important thing that we're trying to do now is networking, making networking work. It's just something that you've got to come up against. Docker, you can forward ports, and that's great until you discover you're trying to run a cluster of some things that every node needs the same port. So you can't map all those ports straight through. You need some way of running a proper network where there are proper IP addresses exposed to the outside world, especially if you're trying to do it across multiple hosts or on multiple clouds. So the obvious answer to that is software-defined networking. There's Open vSwitch, Open Catalyst, Open Data. There's a few of these things, but one that looks very interesting to me is Weave. So I think we kind of decided this is the way we're going to go. So Weave is the RabbitMQ, Alexis from RabbitMQ, his team. So it's a networking layer that can be dropped onto a bunch of Docker hosts, allowing you to seamlessly connect with them. So that's part of the next version roadmap for Docker, is to integrate Weave. And then we've got other things. I mean, you could spend all day naming new Docker ecosystem technologies and services. There's a lot of them. And in here, Kitematic is interesting to me. Rather than using the boot to Docker, Kitematic, because everyone has Macs, so yeah, make it easier to use a Mac. At the moment, we're kind of, I use Ubuntu, but yeah, Kitematic looks good. Flocker, they're doing some interesting things with ZFS and volumes, so integrating Flocker into Clocker is good. And of course, yeah, Weave, yeah, there's lots. It's just, yeah. So, yeah, well, just to end up, yeah. What does Clocker do? It deploys entities as microservices into containers. At the moment, there's some limitations in Docker to do with multiple hosts and networking across them. So Clocker is working, it's evolving to meet the need of applications that want to run in containers across multiple hosts in the cloud. It's on GitHub, Brooklyn Central Clocker, version 0.62, Apache license. So, I mean, lots of people have forked it, but it'd be very nice to see some more pull requests, more blueprints, integrations, better documentation, all the usual stuff that projects need as they're starting up. And yeah, so instead of asking for questions, we've got a couple of questions. So that's what I'd like to find out. I'd like to find out what people need from Docker, where people see it, where do people see it going, what sort of useful features would enhance Docker, what sort of things would make Docker more useful. So yeah, people can think about that. And of course, ask me any questions as well. So.
Okay, so this is what we're going to do. I want to give you guys a chance to think of some questions that you might have. If anybody has any questions right now, please, of course, bring them up. Oh, we've got some right there. Go ahead.
So, how many of the limitations and problems that you mentioned are unique to Docker as compared to OpenStack or other?
Can you repeat the question?
All right, yeah. How many of the limitations with Clocker are unique to Clocker and Docker as opposed to also happening with OpenStack and other cloud environments? Yeah, I think some of the things like only having a private network is very much, it's a Docker issue. Any sensibly, sanely set up OpenStack is going to have public networks and nicely defined network stack and network interfaces. So yeah, some of that is restricted to Docker, but some of it, ways of defining applications that you want to deploy to the cloud. Well, yeah, a nice, neat application definition like the camp blueprints, yeah, well, that's a problem you'll have. You need to define what your apps look like, whether they go on Docker or whether they go onto the cloud. So yeah, it kind of depends, I guess. Anything else?
Any other questions before we move on to our next?
Yeah, we've got demos.
Yeah, we got a couple demos, a couple talks by a few folks. So why don't we go ahead and move on to those?
Yeah.
And then we can ask more questions afterwards. And by the way, don't be afraid. Maybe at the end, I think it'd be worthwhile having almost like a beginner question, because I'll bet you there's a few of you are still kind of wondering, well, I'm trying to understand how this impacts my job, or what I do, or it's going to impact me. So let's talk about that too. But let's go ahead and move on to our first.